Hello, this is Linnea Labens presenting my thesis for the University of Wisconsin-Superior with the assistance of Dr. Deborah Watry. The title of this is Impact of Emojis in Adult Math Instruction. Math has always been a core subject throughout history, along with reading. Math is a subject that students always study no matter their school experience. However, students now don't just need core subjects, but they also need 21st century skills, or skills that will help them be successful in their life outside of school, in the workplace, at home, etc. A lot of teachers use math word problems as a way to develop 21st century skills, as a way for students to practice the flexibility and adaptability skills they'll eventually need. However, many students struggle with math word problems. They don't know how to correctly decode them, the right skills to solve the problem, etc. Some researchers have found that pictures help students with word problems. So this study looks at whether or not emojis can help as well. So the problem is how to adequately prepare today's students with the necessary 21st century skills using real-world applications when correctly solving math word problems. So the purpose of this study, it's a quantitative study to see the effect of the use of emojis in math word problems to improve accuracy and real-world application for adult learners in Northeast Minnesota. Hopefully the outcomes of this study will provide practitioners with potential best practices, and hopefully this study will help students that struggle to figure out what unknown variables are and help them apply their math skills to a variety of situations. Many students complain that, well, where am I going to use this in the real world? Where will I use algebra outside of school? Hopefully this study will help with those frustrations. The research question for this study is, what is the relationship between adult students' math accuracy and the inclusion of emojis in math word problems? I hypothesized that adult student accuracy would be higher on math word problems that include emojis rather than on math problems without emojis. Before the study began, I completed a literature review. I found that Hoagland, Pepin, Baker, Koning, and Gravemeyer found that adding photographs to math word problems increased authenticity for students. So students found the word problems to be more related to their actual life. And they also found the photographs encourage students to stay in a problem-solving mindset and not to revert to a simple answer-getting mindset. Oftentimes when students become frustrated, they just want the right answer and they don't care how they get it. They don't care about learning about the process or the skills. They just want the right answer and to move on. So they found that photographs actually help students really dig in and work with the material to problem solve. And all of this, of course, helps students practice their 21st century skills. Boonin, Reed, Schoenenboom, and Hollis found that pictures help students identify the skill they need to solve the math problem. So including a picture helps students identify, will I add, subtract, multiply, divide, should I guess and check, what am I looking for? Now, of course, when students identify the correct skill, they're also more likely to be accurate in their computation. These pictures were found to also assist students in solving unfamiliar problems they hadn't seen before. And all of this together shows an increase in 21st century skills, specifically in flexibility and adaptability. McCaffrey and Matthews found that algebra math problems that included emojis were answered more accurately. Their study was done on high school students, and they found the students were able to do more complex algebra concepts when emojis were included than they weren't. Students were able to do algebra problems that they didn't even think were algebraic but were actually more complicated than what they had already covered in class. They surmised that emojis make algebra more relatable because students know what a kiwi is or a pants emoji, but they might not necessarily be able to know what X is. Some weaknesses in the literature review is that there wasn't a ton of research out there on emojis, and definitely not a ton out there on math and emojis. The only research I found was McCaffrey and Matthews, which only addresses high school students and algebra. It doesn't address other math concepts or age groups. This study was an explanatory quantitative study. Students were given a survey that included decimal and algebra problems. Some decimal problems included emojis, some did not. Likewise, some algebra problems included emojis and some did not. The survey was set up so you could directly compare the emoji and non-emoji decimal problems with each other, and the algebra, emoji, and non-emoji problems with one another. The population of participants included adult education students in Northeast Minnesota. To be enrolled in an adult education program in Minnesota, students must be above the age of 19, but there's no cap. Predominantly, the students were white and most were female. However, there was a sizable African American population included. In addition, all students were fluent in English. Convenient sampling was used in this survey and study. So any student that walked through the door of the adult education classroom was given the survey without picking and choosing. So any student was given the survey without any sort of picking the best and the brightest. Most adult education programs are one-room schoolhouses, so students come and go when they please. So teachers never know which students are going to be there on which day, or if they'd be there on the day the survey was given. After handed the survey, students were told to do their best and were not given any outside help by teachers, the researcher, peers, posters on the wall, etc. Surveys were corrected for accuracy. So once they were completed, they were corrected for whether or not the student came up with the correct answer. It was not graded on the work that they showed on the paper. The data was analyzed overall by emoji versus non-emoji accuracy, and then analyzed within each math subject of decimals and algebra. Descriptive analysis was used to find mean percentages and questions correct. The results. So on average, the percent correct for emoji decimal problems was 74%, compared to the average percent correct for non-emoji decimal problems was only 61%. It's also clear that the range of accuracy was a little bit bigger on emoji decimal problems. It's also important to note that question number 5 was thrown out. It addressed non-emoji decimal concepts because the previous problem listed the price of one subject notebooks, but then question number 5 asked the price of 3 subject notebooks. Some students still got the correct answer, but many were confused, so the answers to that question were not included in any of the data. Taking a look at algebra, the average percent correct for emoji algebra problems was 58%. Now there was no range on this because only one question addressed emojis and algebra together. Now the average percent correct for non-emoji algebra problems was 58%. So there's just a minor difference between the two. However, it is important to note that as the algebra non-emoji problems went along, student accuracy decreased as the difficulty in the algebra increased. If we zoom out a little bit, take an overall picture, on average, 23 students out of 33 surveys given answered emoji questions correctly, and only 19.5 answered non-emoji questions correctly. So there is a definite difference between those two. So we can see that in decimals, emojis help students be more accurate. In algebra, there really wasn't much of a difference found, only 0.5% difference. So overall, students are performing better on emoji questions than non-emoji questions. And it could very well be that emojis relate a difficult to imagine math concept into an everyday item. Students may not be able to imagine, these difficult math concepts in their mind, but when related to something they know very well, it becomes much easier for them. This research agrees with Hoogland and Boonin that emojis work as a visual representation in math word problems. Hoogland and Boonin only looked at photographs and pictures, but it's clear that emojis just go right along with that. This study does slightly disagree with McCaffrey and Matthews. They did find a difference between emoji algebra problems and non-emoji problems. However, this study did not, but it wasn't much of a difference. The lack of a difference in the algebra problems could be for a few reasons. Only one question addressed emojis in algebra, while 4 questions were non-emoji algebra. So it could be the way statistical analysis works. That's where the slight difference came from. It could also be that the non-emoji algebra problem was broken down more into specific steps, which may have made it more manageable for students to accurately compute the answer. Or it could very well be that students were intimidated when they saw the large chunk of emoji problems in front of them and didn't try as hard as they may have on other questions. So if we revisit our research question, what is the relationship between adult students' math accuracy and the inclusion of emojis in math word problems? This study showed that emojis increase student accuracy in math word problems, specifically in decimals. We can see by this graph here that if we compare the 2 decimal columns and the 2 algebra columns, that the algebra ones are pretty much the same, whereas the decimal emoji is definitely a taller column than the non-emoji decimal. So the study contributes to the current research at hand. It shows that emojis can be helpful in math, specifically with decimals, and we're still not sure yet about algebra or other math topics just because not a ton of research is out there yet, and this research is just the beginning, hopefully. This study showed that there is a need for additional research with math and emojis. There were some limitations in this study. It was completed at the end of the academic year, which means there's less students than other times of the year. Adult education programs are busier at the beginning of the school year in September and around the holidays, and that would just give a larger sample population to pull from. Also, the survey was short. It was only 11 questions, and that definitely changes averages versus a survey with many more questions. Also, the survey was given out over a short time frame, which really restricted the sample population. A longer time frame would definitely provide a larger sample population. For future research, researchers could address the limitations I just listed. They could look at emojis with other math topics, fractions, geometry, data analysis, things like that. Researchers could also look more specifically at the K-12 population instead of just the adult population. It may be that K-12 students do better with emojis because they're more well-versed in it than certain adults. Or researchers could look at the perceptions of emojis in math. Are students intimidated by emojis in math? Or do emojis in their word problems help them be more successful because they think they will do much better. Other recommendations. Current educators could begin supplementing their materials with emoji math problems. They could incorporate them into their PowerPoint presentations, different worksheets they give out, extra fluency work for students that just quite aren't getting it. They could try mixing things up a little bit by adding in emojis. However, I would start with decimals before I began addressing other math concepts, just since there isn't a ton of research out there yet. And publishers could begin incorporating emojis into their textbooks. And these are my references. Thank you for listening.